Have you ever imagined a world where seasons last for decades and the sun doesn't set for 42 consecutive years? A universe where the cycles of light and darkness are so extreme they seem pulled from a science fiction novel? What if I told you that this isn't just a fantastic idea but something that actually happens in our solar system? What we're describing is the reality of Uranus, the seventh planet in our solar system. Uranus is much more than just an icy planet. It's a world that defies the laws of physics as we know them. Imagine a planet rotating on an axis tilted almost 98 degrees relative to the plane of its orbit. While other planets spin like vertical tops, Uranus appears to roll on its side, behaving so strangely it looks like a giant having fun bowling in space. But what could have caused such an extreme tilt? In this cosmic narrative, Uranus is an enigma wrapped in mystery. Its unique features not only fascinate us, but also raise fundamental questions about our understanding of planetary formation. The most accepted theory is that billions of years ago, a massive object, perhaps a lost planet or a gigantic asteroid, collided with Uranus, tilting it onto its side. But the question is, how large was this celestial body? And how powerful was the impact? Collisions between celestial bodies were not rare in the early solar system. On the contrary, they were common. Scientists have hypothesized that an object the size of Mars crashed into Uranus, an event that could have not only tipped its rotational axis, but also altered its entire internal structure. Uranus is also a mystery due to its composition. Scientists believe that beneath its atmosphere of hydrogen, helium, and methane, there could be an ocean of water, ammonia, and other volatile compounds at such pressure and temperature that they form a supercritical fluid. This idea of an internal ocean contributes to a deeper understanding of how Uranus's tilt might affect its rotation and atmosphere. Uranus's rotation has extraordinary effects on its seasonal cycle. While on Earth, seasons change every few months. On Uranus, each pole remains exposed to sunlight for 42 years, followed by an equally long period of darkness. This prolonged exposure creates a completely different seasonal cycle, where the planet's poles shift from one extreme to the other. Imagine life on Uranus, long summers bathed in sunlight and endless winters, where extreme cold and darkness become the norm. Each pole of Uranus experiences a unique situation. During the decades of continuous light, temperatures can rise, while during the periods of darkness, they can drop to extreme levels, far below any earthly standard. This leads us to wonder how life, if it existed, could adapt to such extreme conditions. How could organisms evolve to survive long phases of light or darkness? These questions remain unanswered, but invite us to reflect on life's resilience. Uranus is not just a singular planet. It also holds a fascinating system of moons and rings. Its moons, like Miranda, Ariel, Umbriel, Titania, and Oberon, are icy worlds orbiting the planet. The arrangement of these moons along Uranus's equatorial plane suggests that the event that tilted the planet may have occurred in an ancient era when collisions between celestial bodies were more frequent. Uranus's moons are of great scientific interest, as they may reveal clues about the conditions and dynamics that led to the formation of the solar system. Uranus's rings, although less famous than Saturn's, are another intriguing feature. Composed of dust and icy particles, these rings provide valuable information about the planet's history and evolution. Their existence and composition offer further clues about the conditions that preceded Uranus's tilt. The magnetic field of Uranus is another aspect that has surprised scientists. Unlike Earth, where the magnetic field is relatively aligned with its rotational axis, Uranus's magnetic field is tilted by about 60 degrees relative to the planet's axis. Moreover, this magnetic field does not seem to have a well-defined center, but appears offset from the planet's core. This anomaly has led to new theories about how planetary magnetic fields form and evolve, suggesting that Uranus's history could reveal secrets about the formation of planets and their magnetic dynamics. Despite all the theories and available data, Uranus remains largely unexplored. To date, the only mission to have flown by this icy planet was Voyager 2 in 1986. During this historic flyby, the probe provided close-up images and scientific measurements, revealing fascinating details such as the configuration of its moons and the structure of its magnetic field. However, Voyager 2 quickly moved on, leaving behind far more questions than answers. Future space missions dedicated to Uranus could finally uncover the secrets of its tilt, internal composition, and atmospheric dynamics. Sending an orbiter equipped with advanced instruments capable of measuring its atmosphere, magnetic field, and moons could provide new insights that would not only change our understanding of Uranus, but might also offer us a new perspective on the formation of giant planets as a whole. Uranus represents a fascinating enigma in the universe. Its peculiarities, from its tilted rotation to its extreme seasons, from its anomalous magnetic field to the arrangement of its moons, remind us that, despite the advances in science, there are still profound mysteries to discover. Every new piece of information about Uranus could not only reveal secrets about this icy giant, but also shed light on the origins and evolution of our entire solar system. Thank you for joining us on this fascinating cosmic journey through the wonderful and mysterious reality of Uranus. If this topic intrigued you, don't forget to subscribe to our channel, leave a like, and hit the bell icon to stay updated on our upcoming space adventures.